Here are more ratio test examples. So we want to still test for convergence or divergence. So let's go ahead and try this problem out. So you want to take the sum from n goes from 1 to infinity of negative 10 to the power of n divided by 4 to the 2n plus 1 times 2 by n plus 1. One of the things that you can probably do is use the alternating series test. However, your b sub n is going to be this 1 over this guy, and to prove that that's decreasing might be kind of crazy, but you still can do that. But now, can the ratio test also uh, do this problem? Well, yes, it can, especially when you have like a power raised to something really complicated. So like 4 to the power of 2n plus 1. The ratio test can be really nice because we saw that in the previous problem, whenever we had something like that, it kind of canceled out really nicely. Like this thing canceled out with that part. Okay, so let's go ahead and try to do the ratio test in this case. So what we want to figure out, so using the ratio test, we want to be able to figure out what a sub n is and what a sub n plus 1 is. Okay, so your a sub n is going to be basically just this guy. Okay, negative 10 to the nth power divided by 4 to n plus 1 and then n plus 1. So that's going to be my a sub n. Okay, so then my a sub n plus 1 is going to be just adding plus 1 to this thing. So negative 10 n plus 1 divided by 4 to n plus 1 plus 1 and then n plus 1 plus 1. So basically what I'm doing is that I'm applying an n plus 1 to all of these values of n. So every one of these n's is going to get an n plus 1, okay, as you can see there, okay? So that means that this guy is just going to be negative 10 to the n plus 1, okay, divided by 4, what is this going to be? 2n plus 3, and then n plus 2. Okay, so that's what we're going to have. So this guy is going to be my n plus a sub n plus 1. So now what I want to do, I want to take the limit, okay, of the ratio, these two guys. Limit as n goes to infinity of the absolute value of a sub n plus 1 divided by a sub n. So you're going to take the limit as n goes to infinity. A sub n plus 1 is going to be this guy. So it's going to be this negative 10 n plus 1 divided by 4 to n plus 3 n plus 2 times, okay, or the reciprocal of this guy, which is going to be this. It's going to be the reciprocal 4 to n plus 1 and then n plus 1 divided by negative 10 to the nth power. Okay. So now here's where we're going to have to use a little bit of algebra. So I'm going to have the limit as n goes to infinity. So this guy is going to be just, we can break it up, negative 10 to the n, negative 10 to the first power, divided by, this we can also break it up, 4 2 to the n, 4 to the third power, n plus 2, times 4 2 to the n, 4 to the first power, n plus 1, divided by, this just going to stay the same, negative 10 to the nth power. Okay, so kind of break up all of these exponents using the exponent rules. Okay, so negative 10 to the nth is going to go away. 4 to the 2n is also going to go away. Okay, one of the 4's here, this 4 is going to cancel out one of these 4, so it's going to turn into a 2. Okay, so what I'm going to be left with on the top is the limit as n goes to infinity. This guy right here is just going to be a negative 10. And then you're going to have this n plus 1 that was left over divided by, now you're left with 4 squared. That gives me 16. That's this guy. And then you have n plus 1. N plus 2. Okay. Now, when I take the absolute value, I'm going to take the limit as n goes to infinity. Okay, the absolute value of 10 over 16 is just going to be, of negative 10 over 16 is just going to be 10 over 16. And then the other part is also going to stay the same, n plus 1 over n plus 2. Okay, as the properties of limits, I can pull out this 10 over 16 And I can also divide both of them by 2 if you really want to. So 10 over 16, limit as n goes to infinity of n plus 1 over n plus 2. Notice that here you can use L'Hopital's rule. So this is actually going to give me, well, what is this, 5 over 4? Okay, and then you're going to take, using the L'Hopital's rule, I get limit as n goes to infinity of 1 over 1, which is going to give me 5/4. Okay. My bad. That's not a 4. There should be an 8. Okay, yeah. Okay, that should be an 8. Okay, and then times 1. So this is going to give me 5/8, which is less than 1. Okay, there we go. That's much better. Okay, so because 5/8 is less than 1, okay, and we're using the ratio test, we're going to go way back up, see what the ratio test is. So ratio test, when it was less than 1, we can say that it's going to be absolutely convergent, which actually means that it's convergent. So we can say by ratio test, okay, the sum from n goes from 1 to infinity, negative 10 to the n over 4 to n plus 1 of n plus 1 is convergent. And not only can we say that it's convergent, but it's also absolutely convergent. So we can also say that it's absolutely. Okay, so that's something else that we can say about that problem. Okay, so now let's do one last problem. So let's say you wanted to do the sum from n goes from 0 to infinity of n plus 2 over 2n plus 7. Okay. Now, could you use a ratio test? Absolutely, you can use a ratio test. Okay, so let's go ahead and try to use a ratio test. Okay, so we're going to use the ratio test. So we have to figure out what a sub n is. A sub n is just going to be this one, n plus 2 over 2n plus 7. And then we're just going to do what a sub n plus 1 is, okay? Which is going to be n plus 1 plus 2 divided by 2, n plus 1 plus 7. So this is, on the top, it's going to give me n plus 3. On the bottom, you're going to have a 2n. Then plus 2 plus 7 is just going to give me plus 9. Okay, so now we have our a sub n and our a sub n plus 1. So now all we're going to do is take the limit as n goes to infinity of the absolute value of a sub n plus 1 divided by a sub n. So I have the limit as n goes to infinity. A sub n plus 1 is going to be n plus 3 divided by 2n plus 9 times, and then flip that over 2n plus 7 over n plus 2. Okay, so now what we're going to do, we can't quite get rid of this. The worst thing that you can do is try to get rid of this. You cannot get rid of these two because these are being added to something else. So you can't subtract them, or you can't cancel them. You actually have to FOIL everything out now. Okay, so it's going to give me the limit as n goes to infinity. So I'm going to FOIL this guy out. I'm going to get 2n squared plus 7n plus 6n plus 21 divided by, and I'm going to FOIL this bottom part out too. So you're going to have 2n squared plus 4n plus 9n plus 18. Okay, I think I did that right. 2n squared plus 7n. 6, yes, I think this is correct. 2n squared plus 4n plus 9 plus 18. Okay, so then you have the limit as n goes to infinity, okay, of 2n squared plus 13n plus 21 divided by 2n squared plus, and then 9 plus 4 is going to give me 13n plus 18. Okay, so now what you can do is you can use L'Hopital's rule, or you can divide by the highest power. And actually what you're going to get is 1. So what happens when you get a 1? Well, when you get a 1, if you go way up to the ratio test, when it equals 1, the test is inconclusive. That does not mean that you're done, okay? So this is inconclusive. So when you write your answers, do not just write this. You're not done. You still need to figure out, is this converging or divergent? Okay? This just means that the ratio test did not help you. Okay? So what else could you have done? Okay? So actually, we did a lot of work with this and it didn't even work. What could have we used in the very beginning? We could have just used a test for divergence. We could just take the limit of this particular part, and if this was not equal to 0, then it's divergent. So we're going to use a test for divergence this time. Test for divergence. And if you forgot what the test for divergence was, you can go ahead and watch the video again. So you have the summation from n goes from 0 to infinity of n plus 2 over 2n plus 7. So the test for divergence says that I just got to take the limit of this guy. The limit as n goes to infinity of n plus 2 over 2n plus 7. If I use L'Hopital's rule here, I get that the limit as n goes to infinity is just going to give me 1 over 2. So my answer is 1/2, which is not equal to 0. So by divergence test, the sum from n goes from 0 to infinity of n plus 2 over 2n plus 7 diverges. Okay? So actually, from the very beginning, I could have just used a test for divergence. So what I actually would recommend is start off maybe with a test for divergence, okay? Or maybe something that's a little easier to work with before you start using all these other complicated methods, because this is a lot. Even though everybody seems to like the ratio test a lot, there's usually sometimes some problems that you can easily solve very simply by just either converting it to a geometric series or a telescoping series or a harmonic, or maybe just using the test for divergence. So you can save yourself a lot of algebra by just applying one of the other fundamental methods. Okay, so yeah, this is just one. I wanted to do this problem because sometimes a lot of students tend to like the ratio tests a lot, which is great. It'll work sometimes, but it can save you some time if you just go ahead and just use a regular test for divergence, something that's not as computationally expensive. Okay.